This is the Lynx ELMNTS system. It is a portable, compact demonstration box that will be used to showcase Lynx software demonstrations. It has a touchscreen HMI and an FM antenna on the upper lid. Then, inside, we have our camera lift system, a software-defined radio, power supplies, a motor controller PCB, and our computer board, all integrated together. There is also a power inlet on the back and USB and Ethernet inlets on the side of the case. Here we have our desktop where we can double click on our ELMNTS executable. This will take us into the main menu screen where we can pick any one of our demonstrations. We click on the automotive demo and that takes us to the car dashboard, which has a nice UI display showing the speed and the RPMs of the car, as well as the fuel. It also displays the current time and a scene where a car is being rendered on top of a road, and the speed of it driving on the road is based on the speed of the car. Next, we have the medical dashboard, where an MRI image is on the left, and we take that image and perform a 2D FFT on it to get into the frequency domain. Then we perform a filter as the user chooses the filter type and the filter parameters. Then that's taken back into the spatial domain using an inverse FFT, where it is shown as the output image on the right. Next, we have the RF demonstration, which takes the IQ data from our SDR to sense the radio frequencies in the FM band and plot them on our frequency plot that displays power spectral density of the radio stations relative to the internal ADC of the SDR. The radio can also be enabled, and you can swipe across the frequency plot to demodulate and play whatever station you choose. The aviation demo shows a 3D scene with an aircraft being rendered to the scene. The first couple buttons allow for the plane to be rotated and zoomed in or out. The aviation dashboard program actively listens over a UDP socket for data from a terrain tile server. This will render a 3D tidal map of the Earth for the plane to fly over, similar to what would be seen on in-flight entertainment systems on modern commercial airliners. The third button displays an animated primary flight display, or PFD, in the UI. The last two buttons show a top view of the plane. The fourth button will lock the camera to the plane, while the fifth button locks the camera to the ground, showing the full flight path of the jet. Now we look at the camera tracking demo. For this portion of the video, we set the chroma and luminance values to track red light. Other settings can also be tuned here, such as adding PID to control the servo movement for the camera tracking response. The rendering of the display can be set to different masks, a binary mask based on luminance or chroma, and a combined mask based on both. The camera can also be set to stationary mode, where the camera does not move and it highlights the desired object. For this part of the video, we adjusted the settings to track brighter, whiter areas so the camera could lock onto us and follow our movement. When the user is done with the demo, the lift system retracts the camera back into the case. Here is another demonstration for how the system can track different colors. It gives more of a close-up of our settings menu. This portion shows that the camera can be moved manually using the manual control, and there is a PID control as well.